Hi, I'm Patrick Reagan. Welcome to the Advanced Networking Concepts, Part 5, Cloud Connectivity. During this video, we continue our discussion about the cloud, where we discuss how to connect to the cloud and how to configure some of the basic filtering features. As always, stick around for the practice questions at the end to test your knowledge and help you prepare for the Network Plus exam. If you find this video helpful, don't forget to click the like button, and if you have not already, subscribe to the Pat Has Your Back channel for more tech training content and technical know-how. Here we have a traditional on-premise IT data center next to the infrastructure as a service cloud service. For the storage and database layer, you have the components that make how data is stored. On the on-premise data center, you have a direct access storage, storage area networks, and NAS, as well as the database storage. This connects to the compute services, which has the servers, which are broken down into physical hosts and virtual machines. The network layer has your router and switches, and security is provided by firewalls and network ACLs. Within the infrastructure as a service, you have different storage buckets at the bottom. The compute services have your virtual machines. The networking layer, you define your route tables and subnets. The security layer has the firewall and ACLs. But where the cloud really shines is of the enhancements to many of the basic services, as well as all of the additional services that the cloud provider offers. Many of these services can provide services that you use to run on-premise services, but since they are not always running, cost us less because you only pay for what you use. Cloud providers like AWS, Azure, and Google Cloud Platform utilizes a hierarchy structure of regions and availability zones, or simply zones in GCP, to organize their global infrastructure and ensure high availability and fault tolerance. A region is a geographical distinct area where cloud resources are deployed. They're typically large, independent geographic locations like US, North Virginia, and AWS, East US and Azure, and US Central 1, Iowa, and GCP. Regions are designed to be isolated from each other, meaning a failure in one region should not impact another. This isolation helps with the disaster recovery and compliance requirements, as data residency rules often dictate where data can be stored. Within each region, there are multiple isolated locations called availability zones for AWS or Azure, or zones for GCP. Each availability zone is a physical separate data center or a cluster of data centers with independent power, cooling, networking, and physical security. They are interconnected within the region by redundant, low-latency links. This design ensures that if one availability zone experiences an outage, applications deployed across multiple availability zones within the same region can continue to operate, providing high availability and fault tolerance. Virtual Private Cloud, or VPC, represents a logical, isolated, customizable virtual network within a public cloud provider's infrastructure. AWS uses Virtual Private Cloud, or VPC, Azure Virtual Network uses VNet, and Google Cloud uses VPC Network. They act as your private data center in the cloud, allowing you to define your IP address ranges, creating subnets, configure route tables, and implement network gateways. They can be used to segmenting compute resources within a single cloud account. All your cloud resources, virtual machines, and databases are launched within the isolated network, providing a secure and controlled environment. Subnets are subdivisions of a VPC or VNet. There are smaller, distinct ranges of IP addresses within your larger virtual network. Subnets allow you to logically segment your resources, apply different security policies, and manage network traffic more effectively. For example, you might create a public subnet for internet-facing resources like web servers and a private subnet for back-end servers or databases that require restricted access. To apply network segmentation between subnets, you would use route tables and network access control and instance firewalls. A route table contains a set of rules or routes that you can configure to direct network traffic from your subnet. Using route tables across cloud platforms is fundamentally about defining a map that tells the network how to handle data packets based on their destination IP addresses. Generically, route tables across all providers follow these core principles. Rule-based forwarding. Every route table is a set of rules or routes containing a destination of IP range and CEDAR blocks and an XHOP, which is the target where traffic should be sent, such as a gateway, firewall, or network interface. Default versus custom control. Providers automatically create system or default routes to allow internal communications or local routes and basic internet access. Users create custom route tables to override those defaults for specific needs, like forcing traffic through a security appliance. Granular association. While the scope varies, the general practice is to associate specific routing rules with specific set of cloud resources to isolate or direct their traffic. Longest prefix match. All major platforms resolve overlapping rules by using the most specific match, with the longest CEDAR prefix determine where to send a packet. Outbound traffic focus. In cloud environments, route tables primarily control egress or outbound traffic paths, whereas firewalls or security groups typically handle the allow-deny logic for inbound traffic. And hybrid connectivity. They are essential tools for linking cloud environments to on-premise data centers or other clouds by directing specific IP ranges through VPN or dedicated interconnect gateways. Here's an example of a routing table used in AWS. The first route specified shows the 10.0.0.0/16 network is connected directly. Therefore, any packets aimed at the 10.0.0.0/16 network will be sent out the local link. This is most likely the VPC hosted at AWS. The default gateway, as denoted as 0.0.0.0/0, will route packets to the Internet Gateway, which means packets will be sent out to the Internet. Lastly, the last entry has the packets aimed at 192.168.0.0/16, which is sent to a VPC peering connection, which allows communications with another paired VPC that uses this address range. Controlling traffic involves two primary complementary security mechanisms across major cloud platforms. Network security lists, or network access control lists, are subnet level firewalls, and network security groups are instance level firewalls. Network security lists, also known as network access control lists, serve as an additional optional layer of security that controls traffic at the subnet level, which is traffic entering and leaving the entire subnet. Best practice is to use NACLs as a coarse-grained secondary defense layer or to apply broad deny rules for specific problematic IP ranges. Network security groups, also known as instance-level firewall, act as a virtual firewall for individual resources such as virtual machines. They control traffic to and from specific network interface that they are associated with. Rules are typically defined to allow specific types of traffic, including port, protocol, and source and destination IP. Best practice is to use security groups for granular instance-specific access control. In addition to the basic network access control list and security groups, the major cloud providers offer fully managed cloud-native firewall services that provide advanced next-generation firewall capabilities for centralized deep packet inspection and threat protection. They also offer web application firewalls for application layer security. These services move beyond basic IP port filtering to offer enterprise-grade features such as intrusion prevention systems, URL filtering, and TLS inspection. All three platforms also allow the deployment of third-party network virtual appliances from vendors like Palo Alto Networks, Fortinet, and Checkpoint via their respective marketplaces, offering flexibility for organizations within existing multi-cloud strategies or specific security tool preferences. AWS, Azure, and Google Cloud offer a variety of gateways to manage network traffic flow, including options for connecting to the public internet, managing outbound-only connections, and linking on-premises networks to the cloud. They include internet gateways, NAT gateways, VPN gateways, direct connection gateways, and application gateways and load balancers. Internet gateways provide a necessary logical connection between the cloud network and public internet, enabling bidirectional communication for resources with public IP addresses. AWS has Internet Gateway, or IGW. Azure does not have a single explicit Internet Gateway, but instead, Internet connectivity is the default function of the Azure Virtual Network, or VNet. Google has the default Internet Gateway. NAT gateways are used to allow instances located in private subnets to initiate outbound connections to the Internet or other external services without exposing those instances to unsolicited inbound connections from the Internet. It translates private IPs to a public one. The cloud services have the following NAT gateways. AWS has NAT Gateway, Azure has Azure NAT Gateway, and Google Cloud has Cloud NAT. A VPN gateway, Virtual Private Network Gateway, acts as a secure bridge between your private on-premises infrastructure and your private cloud infrastructure. It provides a cost-effective and relatively quick method for establishing hybrid cloud connectivity by leveraging the public internet as the underlying transport medium while guaranteeing data security through encryption. The connection is established over the public internet using standard secure protocols, primarily IPsec or Internet Protocol Security. Establishing secure tunnels. It manages the creation of encrypted tunnels using the IPsec protocol suite to ensure all data transmitted between the two networks is private and protected from interception on the public internet. Authentication. It handles the authentication process, usually via pre-shared keys or certificates, with the customer gateway, which is the physical device located on the user's premises. And routing private traffic. The gateway ensures the traffic destined for private cloud IP addresses is routed through the secure tunnel rather than being sent over the open internet. This typically involves using Border Gateway Protocol, or BGP, for dynamic routing. The VPN gateways are called AWS uses Virtual Private Gateway and Transit Gateway. The traditional service is the Virtual Private Gateway, which is attached to a single VPC. For more complex network architecture, AWS Transit Gateway can route traffic between multiple on-premise networks and numerous VPCs through a central hub, simplifying network management. Azure uses the Azure VPN Gateway, and the Google Cloud has Highly Available VPN, or HAVPN. A Direct Connection Gateway is a specialized, high-performance service that creates a private, dedicated physical network link between an organization's on-premises infrastructure, such as data centers and offices, and the cloud provider's network, completely bypassing the public internet. Each cloud provider offers its own branded version of this service. AWS has the AWS Direct Connect and the AWS Direct Connect Gateway, which is the global resource used to link multiple VPCs across regions to a single physical connection. Microsoft Azure has Azure Express Route, which uses the Express Route Gateway, also called the VNet Gateway, using the Express Route Gateway type to link the dedicated circuit to a virtual network, or VNet. Google Cloud uses Cloud Interconnect, which is specifically dedicated interconnect or partner interconnect, which uses the cloud router to dynamically exchange routes with the on-premises network. You should use direct connection gateways for high-performance, mission-critical, and large-scale workloads where predictable performance and high security are paramount. You should use a VPN gateway as ideal for quick, cost-effective, and flexible connectivity for smaller workloads or as a backup solution. Many cloud resources, such as virtual machines, may have the following IP addresses. Internal private IP addresses, which are the private IP address that is always assigned to a VM from a range from within its virtual network. This IP is static and remains associated with the network interface for the lifetime of the instance. External or public IP address is where a VM typically receives an external IP address by default for an internet access. By default, this address is dynamic or ephemeral, meaning it can change if the VM is stopped and restarted or deallocated. And lastly, we have static external IPs. You can reserve a static public IP address, often called an elastic IP address in AWS, or reserved IP in GCP, and assign to the VM's network interface if you need a persistent public address. This reserved IP will not change until you explicitly deassociate it. Network virtualization is the transformation of a network that was once hardware dependent into a network that is software based. It decouples the network services from the underlying physical infrastructure, enabling the creation of logical or virtual networks that are independent of the hardware. Network virtualization involves abstracting key components of a network, such as switches, routers, and firewalls, and network interfaces, and implementing them as software-based entities. These virtual components are managed and controlled through software, often via centralized platforms like software-defined networking or network function virtualization frameworks. This allows for more efficient management, scalability, and flexibility in how networks are designed, deployed, and operated. Network Functions Virtualization, or NFV, is a modern networking approach that replaces specialized hardware appliances like routers, firewalls, and load balancers with software-based functions running on standard servers or cloud infrastructure. It uses hypervisors or container platforms to abstract compute, storage, and networking resources. In other words, the virtual devices such as router, switch, or load balancer can run as an appliance or virtual machine running on a hypervisor instead of a dedicated hardware. It allows service providers to deploy, scale, and manage network services more flexible and cost effectively. Question: which of the following is the most closely associated with segmenting compute resources within a single cloud account? Answer: VPC. Which of the following is most closely associated with having a leased line to a public cloud provider? Answer: Direct Connect. Question: which of the following offers the ability to manage access at the cloud VM instance? Answer: Security Group. Question: what is used to control traffic in and out of the subnet? Answer: Network Security Lists. Question: a network administrator needs to implement routing capabilities in a hypervisor. Which of the following should the administrator most likely implement? Answer: NFV. For more information, visit these sites. In summary, a region is a geographical distinct area where cloud resources are deployed. Within each region, there are multiple isolated locations called availability zones or zones. Each availability zone is a physical separate data center or a cluster of data centers with an independent power, cooling, networking, and physical security. Virtual Private Cloud, or VPC, represents a logical, isolated, customizable virtual network within a public cloud provider's infrastructure. Subnets are subdivisions of a VPC or VNet. There are smaller, distinct ranges of IP addresses within your larger virtual network. To apply network segmentation between subnets, you would use route tables and network access control and instant firewalls. A route table contains a set of rules or routes that you can configure to direct network traffic from your subnet. Network security lists, also known as network access control lists, or NACLs, serve as an additional optional layer of security that controls traffic at the subnet level, which is traffic entering and leaving the entire subnet. Network security groups, also known as instance level firewalls, act as a virtual firewall for individual resources such as virtual machines. AWS, Azure, and Google Cloud offers a variety of gateways to manage network traffic flow, including options for connecting to the public internet, managing outbound only connections, and linking on premises networks to the cloud. A VPN gateway, or virtual private network gateway, acts as a secure bridge between your private on-premises infrastructure and your private cloud infrastructure. A direct connection gateway is a specialized high-performance service that creates a private, dedicated physical network link between an organization's on-premises infrastructure, such as data centers and offices, and the cloud provider's network, completely bypassing the public internet. Network virtualization is the transformation of a network that was once hardware dependent into a network that is software based. Network function virtualization, or NFV, is a modern networking approach that replaces specialized hardware appliances like routers, firewalls, and load balancers with software based functions running on standard servers or cloud infrastructure. Thank you for watching this video. The next video will be Advanced Networking Part 6, Network Virtualization. If you like this video, click the like button, and if you have not already, subscribe to the Pat Has Your Back channel. Thank you.